Welcome to Summary Notes, episode number 1 for Unit 2. In this episode, we are going to cover lessons 2.1a to lesson 2.1b. You should have gotten back from the printer and have gotten 3 pieces of paper. First, the first part of the summary notes, which is lesson 2.1a. Then this graph, which we will be referring to in a little bit when we talk about scatter plots and lines of best fit. And then finally, the sheet that will cover information from lesson 2.1b. So let's go ahead and start on our first page. We're going to go ahead and start, as I mentioned before, with the scatter plots and lines of best fit. So in lesson 2.1a, part of the problems that you needed to learn and understand was dealing with scatter plots. Now, we have talked about scatter plots in the past, so creating a scatter plot should be nothing new to you. However, now what we're going to do is we're going to be looking at, now that we can create scatter plots, we're going to look at how to draw the line of best fit and then use that line to answer a couple of questions. So as you can see below, we have 4 steps that we need to go through. And we again are going to be going back and forth between this sheet and the graph that you have printed off. So first I want to start by looking at the graph. Currently we can see that the title is about the emails per day by age. The age then is listed on our x-axis. So again, to review some vocabulary from Unit 1, age is what we call our independent variable. Independent variable. So then when we look on the y-axis, our dependent variable is the average emails per day. So this is our dependent variable. Another thing I want to point out is a scale. When we look at the x-axis for our independent variable, our age is, or the scale is going up by the same amount each time. So I always start at 0, 0, and my first line has a unit of 12, the second line 24, second line 36, 48, and so on. And so this scale, or a scale that I'm going up by on the x-axis, is 12. And then if I go on the y-axis, I have a different scale, but it's going by the same increments. So technically, even though it's not written in, it's going by 5s each time. But every other line, we can see that the 10s are highlighted. What I've been seeing in this year, as well as in the past, a lot of folks are struggling to set up their axes or their scales appropriately, meaning on the x-axis, they do fine by keeping the same interval. So this is by 12, so they keep that same interval throughout. However, on the y-axis, they want to draw a breaking point and then start out their scale. This isn't the best practice, because if you draw a breaking point in, or let's say you start with 10, but then you start going by 30s, that is going to throw off your line of best fit when you go to draw it in. So please make sure that both your x and y axis have and go by the same scale that you choose. Again, they can be different scales for the different axes, but as you go on the axis, you need to have the same scale throughout. Finally, what's nice about this graph is that the line of best fit is already drawn in for you. So as you can see, and what you may have to do in the future is draw your own line of best fit. But as you can see, my line of best fit goes through as many points as possible, or is around as many points as possible. So what our lines of fit try and do is when, or if it wasn't drawn in, we would take our ruler and we would try and draw our line through as many points as possible, or pretty much smack dab in the middle of all the scatter plotted points. So now that we have our scatter plot that has an appropriate scale on each side, is graphed appropriately, and has a line of best fit drawn most appropriately, we are going to have to find the equation for this line of best fit. So the first step in order to find the equation is we need to find 2 points that are either on or near our line. And what's important about that is these points need to span most of the data. So when I say these points need to span most of the data, we're looking for 2 coordinate points. One that is kind of roughly more towards 0 on the x-axis, and then another coordinate point that is a little bit further away from 0. That is going to give us a good idea of the span of our data as we determine our slope. So the 2 points that I'm going to pick are 24, comma 24. So this one is kind of already highlighted here. It's on that line of best fit, as well as 48, 14. So I'm going to go ahead and write that down in my sheet. The first point I'm picking is 24, comma 24, and the second point I'm picking is 48, comma 14. Again, the reason why I picked both of these points is because both of those points fall on my line of best fit, and one is a little bit more closer to 0 on the x-axis, while the other is a little bit further away. So now that I have my 2 points, I'm going to use those points to find the slope. Now, finding the slope from 2 points is something that you should have learned last year in your 8th grade math curriculum. And so when I find the slope, remember, slope is always represented as m, or the variable m. And what we're going to be doing is we're going to be taking our y2 value and subtracting our y1. And then we're going to be dividing by our x2 value subtracted by our x1 value. So what we call this is the change of y's being divided by the change of x. So our slope, remember, is always our y change over our x change. So before I start using this formula, I'm just going to label my points up here. I'm going to call this x1 and this y1. And so for the second coordinate point, I'm going to call 48x2 and 14y2. So what's important to notice is when I named these coordinate points, I put x1 and y1 together because this is an x value and this is a y value. And then I put x2 and y2 together because 48 is an x value and 14 is a y value. The x2 and y2s have to be together and the x1s and y1s have to be together. I could have had this flipped around, meaning I could have called this x2, y2 and this x1, y1, and I would still get the same answer. So now that we have these labeled, I'm going to go ahead and fill in these variables with the appropriate number. So instead of y2, I'm going to put 14. Then I'm going to have the subtraction symbol. And then instead of y1, I'm going to put 24. Then I'm going to divide by x2, which is 48, and subtract off x1, which is 24. So when I do 24 minus 14, I get a value of 10. And when I do 48 minus 24, I get a value of, negative 10 should be on top. 14 minus 24 is negative 10, and then 48 minus 24 is a positive 24. So then what we always like to do is write our slope in most simplest form. So when I look at the values negative 10 and 24, I notice that both of them can be divided by 2 or simplified by dividing by 2. So when I do that, I get a value of negative 5 up top and a positive 12 below. 5 and 12 have no factors that are in common, so this is my most simplest form for my slope. And I can also confirm that this is a correct slope because of the negative symbol. If I go back and look at my graph, I can see that my line of best fit is headed in the negative direction, or it has a negative correlation for the data. So getting a negative answer for my slope means I'm on the correct path in terms of determining the overall function or equation I have to write. So after we determine the slope, the next part is to find the y-intercept. And so that means where the line crosses the y-axis. So in order to find where the line crosses the y-axis, I need to go back to my lovely graph. And when I look at my line of best fit that I had drawn or was already drawn in for me, if I follow this line and I look to see where it hits the y-axis, it looks like it hits exactly at 0, 35. So where it hits the y-axis is at 0, 35. So this means that my y-intercept, or my starting value, is 35.